Okay, it's working, I think. Right. Let's see if this is working now. Okay, seems to be working okay. Okay, I'm going to be checking my settings. I think it's working. Can you just check the sound? Okay, I think the sound's working okay. It's working. Ginger, yes. Hey, there we are. Nice. Will the session be recorded? Yes, it will. It comes out on the YouTube channel, though, a few hours later. Plan to do an hour today to go through those paper 4 questions that are burning as well. So I've got a good selection of questions here for you. Again, I had lots and lots of requests. It's been kind of crazy. So I've tried to pick out as many topics as possible. You can see this topic here is sequences. So we're going to do some sequences work first of all. I had a lot of requests last time for cubic sequences. So you're going to see a kind of twist on that in the very first question. Anybody else? Got vectors requests. Again, hopefully I can take some requests at the end and see what we can do as well. Paper 6, 0607 tips. Paper 6 is always very tricky to prepare. Generally, sequences is quite often for the investigation, so that's one thing you can certainly target. And make sure you know your graphical calculator to do the modelling section, because you'll have to do something with graphical calculator somewhere. Right, we are going to get started on this question. So Marco here is making lovely patterns with grey and white circular mats, and it forms a sequence, and he's counting the number of grey mats. So you can see there are 6 in the first one, and there are 9 grey and then 1 white to give us 10 total. And so you can see how the table is formed, and we need to find and complete the table for pattern 5. Now generally when you have patterns, you want to be looking at the differences between each of the terms, and notice here we have just +3, so we've got +3, +3, +3. So we're just going to add 3 again, and that gives us 18. And this is very typical. They'll start off with some pretty easy questions, finish the sequence, and then they'll get towards the quadratics and cubics later on. This one here, we have to be a little bit more careful. So notice we've got +4, and then we've got +5, and then we have +6. So we get +7, and that's equal then to 28. Now in the chat, can you tell me what kind of sequence do we have in this total number of mats? Let's see if the chat is working. Can someone tell me what that sequence is for the total number of mats? Is it linear? Is it something else? Let's see if the chat is working. Oh, again, a lot of different ones. Quadratic, cubic, arithmetic. Oh, lots of different ones. It is quadratic. It is quadratic because we have a difference of a difference. Notice we go up +1 with our second difference. So just be aware of that this is a quadratic sequence. Okay. Now, next part of the question is we need to find an expression in terms of n for the number of grey mats in pattern n. The biggest mistake that's made in these is you take the wrong sequence. So notice we are taking this top sequence here. Now, the way I've always taught this is a linear sequence, this one, number of grey mats. We have a difference of +3, so we know we have 3n. And then what I do now is look at the 3, I look at the first term of the sequence, 6. What do I add to 3 to get 6? And I just +3. So this is a very easy, quick way of actually working out a linear sequence rather than using the a plus n minus 1d formula, which you can also use as well. Good, 3n plus 3 in the chat, very nice, excellent. Will I do a live add math 0606? Probably not, but there will be a couple of videos coming out on that. Well done in the chat, 3n plus 3. Again, sequences, it's a topic that not necessarily has come up that much, so that's why we're going through a big question today. This next question is a nice, fun one. question D, sorry. We'll quickly do question C. So Marco Maxa makes a pattern with 24 grey mats. So we're still looking at grey. And we need to find the total number of mats. So this is working backwards. We take our nth term. So we take our 3n plus 3. We make it equal to 24. So we're trying to work out how many mats are actually being used. And then we work backwards. So we just minus 3 from both sides. That gives us 3n is equal to 21. And then n is equal to 7. So there's going to be 7 in total. If I go to the mark scheme here. Oh, what have I done there? Oh dear, oh dear, oh dear. I've made a mistake. Who can tell me what the mistake was? I'm getting lots of 7s in the chat. Yeah, thank you for 7s. It asks us for total. Very good. Is total not grey? Excellent. Yeah. So we're actually looking for the total number of mats. Again, so we've got our selection here. And so what do we do then with the 7? So 7's important. We need the 7. But what do we do to the 7 to work out the total number of mats? Who can tell me in the chat? Yep. So we have n being 24 here, yeah? So that's what's important, yeah? So we have n being 24. Need a little bit of a warm up here. So cross this out. We just do 24 times 3. Yeah, which gives us 42 plus 3, and that gives us 45. So the key thing is to make sure you read the question. Okay. Need a bit of a warm up before I do this, yeah? Okay, let's move on to question D. So Marco needs a total of 6 mats to make the first pattern, and he needs a total of 16 mats to make the first 2 patterns. So let's just go back to our table here. So in order to make pattern 1 and pattern 2, he needs to add together 6 and 10, and that gives him 16. And if we're to continue this, so to make the first 3 patterns, although this is not needed for the question, he would then add together, well, 6 and 10, and then the next one, which is 15. Yeah, double check. And that gives us 31. So the first 3 patterns, he would then need 31 mats in total. And you're told it's actually a cubic sequence here. So you're told he needs a total of 1/6 n cubed plus an squared plus bn to make the first n patterns. Find the value of a and find the value of b. Now, one approach you could take is actually just write out the sequence 6, 16, 31, and then do the next one, which would be 50, 21, wasn't it? Yep, so 52. And then work out this cubic sequence. But that takes a long time to do. So there is a quicker way of actually approaching this question using the 2 bits of information that we have in the question. So what we're going to do here is set this up as essentially a simultaneous equation. Good, we're going to make a simultaneous equation here. So the way we're going to do this is we take the very first pattern. So this is when n is equal to 1. So let me put that in brackets. So n is 1. And so all I'm going to do is put, wherever I see an n, I'm going to put a 1. 1 squared plus b lots of 1. And we know that has to equal 6. So we know the first pattern, which has a total of 6 mats, if we put n into our nth term here, we will then generate 6. Now we can simplify this down quite nicely. So we have 1/6 plus a plus b is equal to 6. So keep that equation in mind, and we will come back to that in a moment. For the second pattern, we're going to do exactly the same thing. So we have n is equal to 2. So we put 2 cubed plus a 2 squared plus b lots of 2. And that's going to equal then our new total here, so the 16. So we can simplify this down, so we get 8 over 6 plus 4a plus 2b is equal to 16. So we've then generated our second equation here, 8 over 6 plus 4a plus 2b. Okay, do you want me to go back to the previous question? So I'm just thinking in the chat here. I'll come back to this. Yeah, so let's look at question C again. So Marco makes a pattern with 24 grey mats. Okay, so he has 24. So this question you can just add on 3 each time. So you have 21 and then 24. So we know then that this will be pattern 6 and this will be pattern 7. And we want to work out the total number of mats in this pattern. Okay, so we know it's the 7th one. Let me rub out the quadratic here. And so in order to work out the next difference, we just do plus 8 and plus 9. So that gives us then 36 and then 45. So the answer for question C here is just going to be equal to 45. Maybe that's just a better way of explaining that question here, part C. If I don't get an A star, I'll be coming for you, ginger guy. Yeah, okay. Super. Is that a better way of explaining that question, part C? Okay. Cool. Okay, let's move on. So let's go on to question D here. So we've got our simultaneous equations. However, it's a little bit untidy at the moment. So we're going to need a little bit of space in order to actually produce this and actually solve this. So what I would do here, first of all, is simplify this down. So let's take the 1 over 6 plus a plus b is equal to 6. And let's just minus a 6th from both sides. So if we do that, this cancels, giving us a plus b. And then 6 minus a 6th. Notice 6 is the same as 36 over 6. So we subtract a 6th from that. We're going to get 35 over 6. So that's our first equation, and we can work with that in a moment. Now let's take the second one. So we take the 8 over 6 plus 4a plus 2b is equal to 16. Again, we can do the same thing. So if we take 16, again, we can actually unsimplify this. Again, you've got a calculator, so please use it. So if you have 16 times 6, you can have 96 over 6. So if we subtract 8 over 6 from both sides, we then get 4a plus 2b is equal to, well, 96 over 6 minus 8 over 6. That's going to give us 88 over 6. So we have our two equations here. Again, a little bit on the ugly side, but we can certainly work with these and solve them. I'm trying to keep up with the chat as I'm going through these questions. Okay, so I'll just focus on this. There's a lot of spam going on, so I don't think that's very useful. So the way that we solve this, the easiest way to do this is just to take one of these equations and actually make the a's or the b's the same. Notice we've got 1a and 1b, but we can make this into 2b. So what I'm going to do is times by 2 on both sides of this equation. That gives me then 2a plus 2b is equal to 70 over 6. And now this allows me to subtract the two equations from each other. 4a minus 2a is 2a. 2b minus 2b, that just disappears. 88 over 6 minus 70 over 6, that's equal to 18 over 6. And again, we can simplify this fraction down to give us just 9 over 3. And then if we divide by 2, a then is equal to 9 over 6, which can simplify again by dividing through by 3. and that gives us 3 over 2. So A here is equal to 3 over 2. If you look at the mark scheme here, they're happy. Just keep it at 3 over 2. Don't have to do 1.5 or anything like that. Once we know what A is here, we can sub A in this first equation. This gives us then 3 over 2 plus B is equal to 35 over 6. So we subtract minus 3 over 2 from both sides. And we can just pop it in. Minus 3 over 2. And that gives us 4 1/3 according to my calculator. Again, we can also write this as a mixed number as 13 over 3. Notice they like it here at 13 over 3, but you can have both here in order to get all the 6 marks. A whopping 6-mark question here. I'm only really going through harder questions today. Right, any questions on that? Hopefully there's not a lot of spam in the chat. It makes my life a bit easier. This definitely deserves 10 marks or something. Yeah, it's certainly a long part. Slow mode disable it. People are spamming like crazy. Yeah. Slow mode. Oh, I don't even know how to put it on slow mode. Let's see if I can work this out. So if I go to my streaming settings, does anyone know where that would be? Let's have a look. Stream setting. We'll be covering domain and range today. Just wait for this page. Yep, I'm trying to look at slow mode, but my computer's being slow to put this into slow mode. Okay, so that's not too helpful. If you know where that is in the options, please let me know in the chat. How to put it into slow mode, because I don't know is a quick answer. Very quick answer. Choose the edit button in the bottom left corner. Edit button. That's channel level settings. Pop out dashboard. I'm in the bottom left corner. Oh, edit chat. Ah. Boom. yeah. Well, I'm looking. I'm doing my best. I do not see the edit button. Oh god. Let's have a look. Add stream marker. Highlight video. Delay ads. I'm looking. I'm definitely looking. Pop out dashboard. Go to stream health. Okay. Stream is health. Stream is excellent. Edit button. Ah, this edit button. Okay. Ah, yes. And you go to customization. Yep, I have seen this. Slow mode. There we are. It's now saved. There we are. Got there. Right. Slow mode is on. There we are. That's going to help. So I'll show you the mark scheme for the questions that we just did. So that's our first sequences question. Again, I had a lot of requests on sequences. So the next topic, which I've had requests on, is mensuration. This is no surprise that I'm going to go through some mensuration questions here. So if there's one thing I could say really focus on paper 4 with calculator, mensuration percentages are probably the 2 things I would talk about. Yeah, it's now on the slow mode, so it is now working. Super duper. So let's go through this. A solid hemisphere, keyword hemisphere, as volume 230 cubic centimeters. Notice a hemisphere, English is not your first language. This is just half a sphere. So I don't get students like learn things off by heart a lot, but certainly with key terms like hemisphere, you need to know that is essentially half a sphere. We're told to calculate the radius of the hemisphere. Now notice we're given a sphere, so a hemisphere formula is related, and that is a half of this. So it's going to be, the volume is going to be 2/3 pi r cubed. So here we're given the volume and we want to work out the radius. So I take this formula, I'm going to put in 230 equals to 2/3 pi r cubed. And now we want to work out the radius. So we want to do some working. So we get r equals at the end. Okay, so the way that we do this, I'm just looking at the chat at the same time, is work backwards. Generally, before I do anything here, I'm just going to flip the equation. So r is on the left-hand side. And then we can go, well, I've got a times 2/3 pi here. What's the opposite of timesing by 2/3 pi? Well, dividing by 2/3 pi on both sides. If I do this, notice I'm not rushing to my calculator at this point. I cancel here, leaving me just r cubed is equal to 230 over 2/3 pi. And then the opposite of cubing something is the cube root on both sides. And notice I get the cube root of 230 over 2/3 pi. Only at this point would I then rush to my calculator and actually use my calculator to work it out. So let's get my handy calculator out here. So I've got a lovely emulator here. So you should have this calculator or something similar. So let me show you on my calculator how we actually work this out. So we want the cube root button, so shift and here. Then we want a fraction, so I've used the fraction button, then 230, and then down below I want 2/3 pi, so we go 2/3. Notice you need to be quite quick with doing this, and then the pi button is shift and this button down here. Press the equals button, and then we get 4.7887. 4.7887. Now generally I'm going to round this to, generally I'll do it to 2 decimal places, so I do 4.79 centimeters. Often it's a question that I get asked. What should you round to? Should you round to 1 decimal place, 2 decimal places, 3 significant figures? My general rule is on 0580, which we're talking about really today, I would do it to 2 decimal places. On 0607, if you're doing that course, generally I do it at 3 significant figures. So that's a general rule of thumb. You can't really go wrong if you do that. Notice I got the most accurate answer possible by using this working that we've just talked about. So you get 2 method marks just for writing down here this part here. So you don't need to write that much working, but you need to have enough working that if this goes wrong for whatever reason, you can still pick up the 2 method marks. Okay, the question here, all the zones get the formula paper? Yes, they do. Yeah, so you do get the formula. This is an older question, so that's why they give you the formula in the question, but now you have to use the formula from the formula sheet. Okay, good question. Why do we use 2/3 rather than 4/3? Because we're looking for a hemisphere. And remember, hemisphere is half a sphere, so we don't want 4/3 pi r cubed, we want half of that, so that's 2/3 pi r cubed. Okay, let's move on. Again, you can watch the recording of this afterwards. So now we have a solid cylinder with radius 1.6 centimeters attached to the hemisphere to make a toy. So we've got our hemisphere that we just talked about, and the total volume of the toy is 300 cubic centimeters. So notice this hemisphere has 230 cubic centimeters. Therefore, this cylinder must be 70 cubic centimeters. And from that information, we need to find the height of the cylinder. So the way that we do this is we need to know the volume of the cylinder. So volume of cylinder. Who can tell me in the chat what the formula for that is? This is getting you to use your formula sheet so you know exactly where it is and how to access the formula. What is the volume of a cylinder? The chat, come on. Tell me what that is. Let's take a sip of coffee. What is the volume of the cylinder? Pi r squared h, good, thank you. Pi r squared h. Most of you are saying pi r squared h, which is good. This is what it should be. So pi r squared h. Now, whenever I get a question like this, I've got my formula, and now I just put in the information I have. So I know the formula for the volume is 70, so I put 70 in here. I know pi is just a number. R here we're told, remember we're told here the radius is 1.6 centimeters, so we put 1.6 squared. And h that we don't know, so that is what we're looking for. So at this point, I've got all the information that I need. Again, when I'm working with equations here, I'll generally flip these over. So I have the h on, or the thing I'm looking for, on the left-hand side. And now I can just divide through by pi and 1.6 squared on both sides. So this cancels, giving us just h. And notice, not rushing to my calculator until the very last point here. So only at this point will I go to my calculator and then go, okay, fraction button, 70 over, let's get the pi button, pi 1.6 squared, press equals, and then we get our answer for the height, 8.703. And again, I'm going to round to 2 decimal places, so 8.70. Okay, notice you don't need the 0 in the mark scheme here. But again, making sure you've got enough working. So this is enough working to get the 2 marks, and then putting the answer in accurately. Okay, any questions on that? 8.70, 8.70. Very, very good. Well done. Can I go a bit slower? I'll do my best. I certainly will do my best here. Asymptotes. Yeah, I think that's tripped up a few people on paper 2, yeah? Why 70 cubic centimeters? Because we know the whole thing is 300. We know from the previous question we have 230 for the hemisphere. So what's the difference between 230 and 300? That's going to be 70. Super. So do we lose marks for not writing the formula for the working? That's a great question, Advid. Generally what happens, like when you mark I mean, I've been an IB marker before, not an iGCSE marker, but the general way you do this, you look at the cubic centimeters, calculate the radius. So the way I do this is, I've got 19,200, and the shape before has 300. So to find the scale factor, we'll talk about what kind of scale factor this is. We just divide one by the other. Now you can do big by small or small by big. I'm doing big by small here. And if I put this into my calculator, so I take the new volume and divide by the old volume, I get then 64. However, this is not just any scale factor, because we're working in cubic units. This is the volume scale factor. And in order to work out the radius, well, the radius is a length. So we need the scale factor, but the length scale factor. So who can tell me what we do with the 64 to go from the volume scale factor to the length scale factor? Who can tell me that in the chat? Who can tell me in the chat? What do I do now with the 64 to work out the length scale factor? Not square root, cube root. Yes, well done. Remember, we've got a cube unit, cubic centimeters, why we say cubic centimeters. So we need to find the cube root of 64, which is equal to 4. So our scale factor for length here is equal to 4. Once we have that, well, we know the cylinder radius is 1.6, and we want to work out the radius for the toy, the similar toy, so we just times it by 4. So we take that to be 6.4 centimeters. Again, you can just do that last part on the calculator. Okay, I think that's a nice way of actually going about doing this kind of question. I know a lot of people, if you look at the mark scheme, they do all this kind of stuff and it's kind of ugly. But if you break it down, what scale factor do I have? What scale factor am I looking for? And that'll help you to do the cube root or the square root or square or cube. Okay, so this helps you a lot of different kind of question. So this is the volume of the big. Let me put volume of big, and this is the volume of the small shape. The 300 comes from the second part of the question, the total volume of the small shape. 19,200 comes from the question. We're told that in the question. Okay, I'll just quickly mention about the new predicted paper 4, which is in the description of this live. So I've gone through your paper 2 comments, so like what's come up basically, and I come up with a new predicted paper. Okay, so it's available. You can click the link, you can buy it for €20. And what this gives you is, first of all, challenging questions. So I put a really nasty domain and range question in there to really get you going, really thinking about these topics, and also topics that haven't appeared so much so far. So mensuration is a good topic that we've talked about. Sequences haven't appeared too much so far. And the next question we're going to look at, which is functions, hasn't really appeared that much either, which is why we're going through that today. So this predicted paper 4 is here to design. It's got full solutions as well, so you can really get that last minute practice before tomorrow. Okay, that's my little blurb about the predicted paper 4. Let's get back into another question. So this is a function question, very typical. You're given like 2 or 3 functions, and then you have to do some stuff with it. The first one here is a composite function, so h of f of 8 of 3. So the way that we do this with functions, and you need to think about this and write this down, we always work right to left with functions. Now notice that's sometimes a bit counterintuitive, because in English, for example, we write from left to right. Yeah, I start at the left and work to right. I think, and you can correct me if I'm wrong, Arabic is a language that works right to left. I think Japanese is. If you can tell me in the chat if that's actually correct. So I think Arabic and Japanese are both right to left languages, and functions also work the same way. So we have to work from right to left. So what does that mean? So the first thing that we do here is we work out f of 8 of 3 first. Now, the way that we do this is we take the function over here, so 8 minus 3x. Wherever I see an x, I'm going to put an 8 over 3. So 8 minus 3 lots of 8 over 3. So these 3's cancel, giving us 8 minus 8, which is 0. Once I know that this part is equal to 0, let's get the trusty highlighter out here. So here, wherever I see that function, I can now just put 0, so h of 0, which gives me 2 to the power of 0, which we should all know in the chat. 2 to the power of 0, what's it going to be? What's it going to be? 2 to the power of 0. Harvinder, yes, you're the first person to put down 1. Good. So the answer is just 1. Very straightforward. Okay. Harvinder, I'll give you a super like if I could. Rachel Lawrence, yes, 1 with 3 exclamation marks. Be careful with exclamation marks, because there's something called factorial, which you'll find out in A-level or IB. Cool. Next part. So similar idea. So we have h of minus 2. So we do this part first. So h of minus 2, that's 2 to the power of minus 2. Again, it's great for your indices work. So what is 2 to the power of minus 2 here? Come on, chat. What's 2 to the power of minus 2? Work from right to left. So we do h of minus 2 first. What's it going to be? 1 over 4, very nice, 1 over 4. Now the 1 over 4's come in. And now we work out g of 1 over 4, which gets a bit trickier here, because we get 10 over 1/4 plus 1, which looks kind of ugly. Yeah, you look at that and go, oh, 10 divided by 1/4 plus 1. But don't forget you have your calculator. What students are really bad at sometimes, they get so paper 2 obsessed with like non-calculator skills. Why don't you just put this in your calculator and just avoid any problems like that? So you just go 10 over 1/4. And this is probably quicker than just trying to work out yourself. And if you do this correctly, you should get the answer of 8. So we get 8 here. Okay. Did any of you do that non-calculator, by the way? I'm interested, because one of the tips about paper 4 is don't forget your calculator can do tons of stuff you can check. In fact, it's a little bit of a segue. If you go to your calculator and you go to the menu, notice some of you don't have these functions in the calculator. You've got far more functions than you probably know. So for example, there's usually an equation function. And say I've got a polynomial and I want to solve one of degree 2. You can actually just type in, okay, so I've got 1 here. And then let's just call this 1 and let's call that minus 6. So you can type in the quadratic that you want to solve. You press equals, and it'll give you the two answers. So it'll give you x1 and x2, yeah? It even give you the minimum points. It'll give you all kinds of things. So your calculator has a lot of these tools here, and you're allowed to use this calculator that I'm showing you here. Of course, you can't use it to actually work out like the answer just directly. You have to show you're working, but you can use it to check. And a lot of students forget about that. Okay, let's look at inverse functions. So inverse functions, I have a very step-by-step method. Again, you can't really go wrong with it. So the first thing with inverse functions, we write down the function equal to y. So y equals 10 over x plus 1. So that's my first step. Just make the function equal to y. Now, the way I teach it generally is I get you to switch it first, because students often forget to switch. So we switch the x and y, so x equals 10 over y plus 1. And then the third step is to make y the subject. So what that means in real English is you need to do some algebra so that you get y equals. As you're solving this, you can ask me any burning questions. My volume's on full. It's on full. I'm lagging. Okay. So I'm getting 10 over x minus 1, 10 over x minus 1, 10 over x plus 1, 10 minus x over x, which can simplify to 10 over x minus 1. Okay. So I'm going to speed through this. The way I would do this is just times by y plus 1. Then expand, so xy plus x is equal to 10. Then we have xy is equal to 10 minus x. And then y equals 10 minus x over x, which can be simplified to 10 over x minus 1. I'll be interested to see what they have here. Yeah, they can take both answers, yeah. What do I prefer? I think I prefer 10 over x minus 1 here. But that's a personal preference for 3 marks. I can speak even louder if you so wish. I've got a very teachery voice, yeah. I teach full-time, by the way. I'm a full-time teacher. Just doing this afternoon session to help you all out before your exam tomorrow. So I'm teaching a lot of older year groups tomorrow. Shout out to my Quarter Wolf class and year 11 class. If they're in the chat, hello. Thank you for joining. Yeah, shout out to my classes. Shout out to my classes. Okay, now this is a great question. I love this question, and it comes up occasionally. So we got f inverse f of 5. Now, what's the answer to this question here? My hint to you is it's only 1 mark, and there is a reason it's only 1 mark. Edvit has put down 5 straight away. I love it. Straight away got down 5. 5, 5, 5, 5. Good. Notice f inverse and f are opposite operations, so they just cancel, and you're just left with 5. If it's a 1 mark question, it should be something fairly straightforward. So do keep that in mind. Please don't be that student that does f of 5, whatever that is. So I think it's minus 7, then you do f inverse of... Yeah, please don't do this. Yeah, it just takes too much time. Angry Ginge and Ginger Mathematician could be the top 2 ginger people. Yeah, maybe. Okay, last question. Again, we've got some algebraic fractions. So even though we're covering just functions, we've actually got some algebraic fractions here. And this is often a good chunky 3 marks, so it's worth practicing. So write f of x and g of x as a single fraction. So we have 8 minus 3x plus 10 over x plus 1. Easiest way to do this is we can just take this part here and then just multiply by x plus 1 over x plus 1, top and bottom, because you're essentially multiplying by 1. So we get 8 minus 3x, x plus 1, over x plus 1, plus 10 over x plus 1. And we just use FOIL to expand out the bracket. So if we do that, we get 8x plus 8 minus 3x squared minus 3x plus 10. I'm going into the answer bit here. Over x plus 1. And then we just tidy this up. So get minus 3x squared. 8x minus 3x is plus 5x. 10 plus 8 is 18 over x plus 1. I assume they want it written in that form. Yeah, but I don't think there's any reason to change that form. Okay. Notice sometimes how quickly you have to work through some of these questions. Yeah, you want to try and save time then for some of the other tricky questions that are coming through. Manor is on it. Well done, Manor. How to find the inverse of h? That is a nice question. So, how to find the inverse of this? So the opposite of an exponential function is just log. So the actual inverse here, I'm not sure if you've been taught this, is log base 2. So this would be the inverse if they do ask you. Good question. Ginger, will paper be hard? Everyone asks that question every year. Will the paper be hard? Well, paper 2 seemed to go down pretty well. Okay, so that's a good sign. Will paper 4 be harder? And they need to try and balance it. It's a new syllabus, so they'll probably be on the nicer side here. Yeah, it's not in syllabus what I just did there, but why not? Okay, there's the mark scheme there, so you can go through where you picked up your marks. I think I had one other question. Oh yeah, I want to go through this question. There was a reason I picked out this question, so I will talk about it. So I'll go through this question, which is a nice mix of coordinate geometry and some inequalities, and then you can ask me your final burning questions. So this one here, very, very common, this idea of perpendicular in some way. Now the classic question usually is perpendicular bisector, but in this case it's a slight twist on this. So find the equation of the straight line that is perpendicular to the line y equals a half x plus 1 and passes through the point 1, 3. So as soon as I see perpendicular, as soon as I see this word, I'm thinking the negative reciprocal of the gradient. Now that's a very complicated word, for I'm looking at the gradient of the straight line I have. I flip the fraction, so 2 over 1, and then change the sign. So I've got a positive here, so I'm going to have a negative. So the gradient of the perpendicular, the m, is going to be equal to minus 2. So go through that again. I look at the gradient of the line I have, flip the fraction, change it from a plus to a minus. That gives me the gradient of the perpendicular. Therefore, the line that we're looking for has the equation of y equals minus 2x plus c, and we still don't know what that c is, but that's where this point comes in. So we know x is 1 when y is 3. So when x is 1, y is 3. So let's just put it in. 3 equals minus 2 lots of 1 plus c. 3 equals minus 2 plus c. Therefore, c is equal to 5. So our final answer for the line will be y equals minus 2x plus 5. Again, generally you just want it written in that form. Sometimes teachers like it written in this form. That's also possible. Or even this form. So you'll see all of these. These are all the same as this answer here. Thank you, Mr. Shino. Love you. I love it. Love it. Can't believe how many people in the chat. This is 266. I'm not sure if that's actually accurate or not. Can we use y minus y1? Yes, yes. So what you're talking about here is this formula. So y minus y1 equals mx minus x1. So once you know the gradient, you can just do y minus 3 is equal to minus 2x minus 1. This is the formula you're meaning. Yes, you can. It's interesting you bring this up because at IB, there was an IB question a while ago where you couldn't actually solve it using what I've done here, but you had to use the y minus y1 formula. So it's useful to know and it sets you up nicely for IB. Hi, can you speak German? Ja, ich spreche fließend Deutsch. Ich kann es natürlich auf Deutsch erzählen, diese Gleichung von dieser gerade Linie, das wir haben. Das kann ich auch machen. That's my German done for today. Ginger got a new hairstyle. My hair just grew. Yeah. You can find out my real name if you look hard enough. Yeah. Okay. There is one more thing I want to talk about before you can ask me general questions, and it's this question here, because I've had some points here about shading inequalities and linear programming, and I think students get confused. Like, what will actually appear in 2025? So linear programming and shading inequalities. Shading inequalities is still in the syllabus. So a question like this could be given. So here you need to find the three inequalities that define this region. So the way that we do this is we find the equation of this line, and of this line. Now this one is fairly straightforward. This is just x equals 2. Because notice at any point here, this is 2, 7, this is 2, 6, this is 2, 0. All the x coordinates are equal to 2. This is why we can call it x equals 2. This line here is y equals 5, and you can use a similar kind of working to actually find that. The trickier part is this particular line here. Notice that there is no y, well, the y-intercept is 0, so there's no c is just 0. And notice our gradient here, we go 2 along and 1 up. So this is the line y equals a half x. So to do this kind of question, shading inequalities, which is on your syllabus, so make sure you do revise it, you need to know these lines. And now we need to work out if we're going to do greater than or less than, this kind of thing. So notice these are all filled in lines, so we're only using greater than or equal to or less than or equal to. We're going to the right of this line, so we want x is greater than or equal to 2. We want below this line, so y is less than or equal to 5. And we want above this line, so we want y is greater than or equal to a half x. Now notice these inequalities you can write the other way round. I've written it the same way as the mark scheme has here as well. This topic is in the syllabus still. However, and this is why I bring this point up, this point here, find the point x, y of integer coordinates inside the region such that 3x plus 5y equals 35. This style of question will not be in. So I won't go through it, of course, because you don't necessarily need to know it. But this kind of linear programming idea, which is usually like a second part of a question, that is not in. So linear programming is not in, but they could still ask you to shade inequalities. Hopefully, yeah, good, exactly. Isn't linear programming not in syllabus? That's what I mean. This is not in big letters. Okay, so please, you don't have to revise that part, although it's kind of linked and it's a fairly straightforward thing to work out. So I put this question in one because it hasn't really appeared that much, but also just to make this point between inequalities and linear programming, and then what will be in and what won't be in. Love your beard. Oh, thank you, Gunter. Thank you. Okay, so there's mark scheme. I was going to go through one more question, but before I do that, are there any burning questions? Let's get a couple of questions from the audience, and then I'll go through this question. Because I know some people struggle with these kind of geometric worded questions that go into quadratics. Any burning questions about the exam tomorrow? I can only get through as much as I can. I've got about an hour. I've got about another 10 minutes or so. If you're stuck on vectors, by the way, I've had this quite a lot. I've done a lot of work on vectors. In fact, so if I open up YouTube, I'm going to open up YouTube here. The easiest way to find anything that I've done. By the way, I know some of you are iGCSE Success fans. So I do keep an eye on that channel. So all you need to do is type in, say you want to do vectors, yeah? So vectors, Ginger Mathematician, if you type that in. Notice I've done a couple of videos, so all of iGCSE vectors. I've also done iGCSE Advanced Vectors Masterclass as well. So again, there are a couple of videos out there. If you're ever stuck on a topic, just type in what the topic is, Ginger Mathematician. I've probably done a video on it at some point somewhere. Yeah, if you type in say logarithms if you're doing 067 course. Again, I've got lots of things out there, yeah? So please do use all the resources that are out there. Super. Mathlete by Said, rah, yeah, my side, yeah, I mean, there are lots of good YouTubers out there. Zamatics, I know one of the issues with like Zamatics and Mathlete by Zard is sometimes they speak in Urdu, I think. So this is all in English, apart from my occasional German, but that's fine. Okay, got 5 minutes, so let's go through one more question. So in this question, all measurements are in meters, that's good to know. The diagram shows a right-angled triangle, and from this information, it doesn't give you any more hints here, we need to find this quadratic. So as soon as I see this, I've got 1, 2, 3 sides of a triangle. It's a right-angled triangle. There are no angles, so no trigonometry. So I have to be using Pythagoras in some way, because I have a right-angled triangle with 3 sides. So then I go, what is Pythagoras? And Pythagoras is simply a squared plus b squared is equal to c squared, where this is a, b, and c. So I then go, okay, we've got x squared plus, now be careful here, 2x minus 3 all squared, so we're squaring the whole thing, is equal to 6 squared. And if we simplify this out, notice 2x minus 3 all squared is just timesing by itself. So 2x minus 3 times 2x minus 3 is equal to 36. This case is just an algebra exercise. So we're going to multiply out the brackets using FOIL or the eyebrow. Lots of ways to describe it. So we get 4x squared minus 6x minus 6x. Notice how quickly I'm doing this algebra because it practices again and again. It's really important. So that gives us then 5x squared minus 12x plus 9 is equal to 36. And that means then that 5x squared minus 12x, minusing 36 from both sides, minus 27 is equal to 0. So it's very common this kind of question does come up. That you get some information. Now this can vary. It could be a speed, distance, time question. It could be a geometric question like this. Just some written information. And you have to work out a quadratic of some kind. Okay, hopefully that makes sense. Yeah, I've had about frustrums, yeah. So a frustrum, by the way, if you're wondering what a frustrum is, it's when you get a shape that looks like this. I'm very bad at drawing, but got better over the years with maths. The key thing with a frustrum is you work out the volume of the large cone. So, forget a blue pen out here. You work out the volume of this cone, click blue, and then you subtract the volume of the smaller cone, which is this one. Yeah, volume of black. So that's your general strategy with a frustum. Yeah, so don't worry too much about it. Is domain and range in syllabus? Yes, I did a video on domain and range. Type in domain and range ginger, you'll find it. With this question, as is very common, they take the quadratic and you have to solve it. Notice this one, because you're doing it to 2 decimal places, you're going to have to use the quadratic formula, which is on your formula sheet, so you don't need to memorize this off by heart. So b squared minus 4ac all over 2a. Okay, and then you can work out x from there. Yeah, surface area is harder in the frustrum because surface area of a cone. Now, that's actually in my predicted paper. I actually give you the formula for that. So if they do test you on that, they'll give you the formula for the surface area. I'm Team Ginger. Great to hear. What formulas do we need to memorize? Well, if you go to my cheat sheet, so type in Ginger cheat sheet into YouTube, you'll actually find my cheat sheet, which gives you all the formulas that you need, including the ones on the formula sheet and ones that are not. Is my name really Ginger? No. You can find my name. It's out there. If I watch all of your iGCSE paper 4, will I be revising the paper? At least the main topics, yeah, for sure. But again, the entire playlist, I've got a huge playlist full of every possible topic you could cover. Again, it's all there. Ginger, awesome. Thank you. Thank you. Asymptotes. Yeah, let's talk about asymptotes. Yeah, this seems to be coming up a little bit. So, all an asymptote is, if you take a function like y equals 1 over x, let's take a nice basic function, then that means you get this kind of weird function where you have asymptotes of the x and y axis. You find it by taking the bottom of the fraction and make it equal to 0. So that's where we get our asymptote x equals 0. Yes, AS Maths. So AS Maths paper 1 is pretty much done. So got a nice big playlist that goes through that. I'm expanding paper 3 and paper 5. That's the plan. So if you are doing A levels, do keep onto the channel because paper 1 is pretty much finished. Paper 3 and paper 5, I did do a predicted paper for paper 1 as well. So eventually the idea will be to finish off paper 3 and paper 5 and probably expand into mechanics. That's probably the route to go down. Ginger, why don't you provide videos with the resources you sell? I definitely buy it that way. Well, I mean, the biggest plan at some point is to actually make an entire video course. That would be the best thing to do. But I think I'd probably put that on YouTube. I don't think I'd just sell that. I'd just sit down one day, record 10 hours of video of me just explaining the entire course. But similar to what GCSE Maths Tutor has done, but for iGCSE. Give me a like in the chat if you like that idea of me just sitting down, doing the whole course in 10 hours. Will you do IB? I currently teach IB SLAA. I've taught all 4 different courses at some point. So HOAI used to be my course, like used to teach that for years. Then I taught HOAA for a bit. I've taught now IB SLAA, so I know all the courses. Again, I'd like to expand the IB content for sure. Where do I come from? I come from England, so I come from a small town called Canterbury, which is known for the Archbishop of Canterbury. I come from there. Glad you enjoy the content. Yeah, it's been a long road. Like the content initially came out for 0607. My students struggle with paper 6 in particular, also paper 2 to an extent, and the non-calculator, and now just created some videos, not the best quality videos, but my typical explanation, and it's just gone from there basically. Sending love from Sudan. Hopefully everything's okay in Sudan. I'm sure I read on the news somewhere there was something happening in Khartoum, but you can correct me if I'm wrong. I think domain and range will appear in some way. Right, I think we've got that 5 minutes. I'll do them for 5 minutes and then I'll stop here. Again, if you haven't checked out the new predicted paper, you can go in the description of this video and purchase it. That might give you... I've talked about that in a video. I have a wife and kids. I have a young baby daughter. I think I mentioned that in a video. Okay, hello from Indonesia. Never been to Indonesia. It'd be a great country to go to. Go to Bali. Yeah. Ginger, do you play chess? If you search my name, you'll find I played in the British Chess Championship in 2015. So I'm a pretty good chess player. I used to be about 2100. Pretty strong. How accurate are your predicted papers? I would say roughly 60%, 70%. It depends on the year, depends on what kind of questions they put. Yeah, I heard about the predicted paper getting leaked. Yeah, I will deal with that as it comes. Great to hear you from Malaysia. My name is Sam. Yes, that is right. From Belarus. Oh, not too far away from where I am here. Do I teach in person? Yes, I taught as head of maths for 5 years. I think it was 5 years or 6 years. Can't remember. In international school. Now I'm in a slightly different school. A bilingual school, so English and German. So yeah, more or less I could teach in German as well. I'm from England originally, but I now live in Germany. Yeah. Okay. Any more questions? Any more burning questions, either about the exam, about me, or anything else you'd like to know? And then we'll stop the video there. I think differentiation's already come up on paper 2, so that's why I haven't gone through that really. Okay, I'm going to stop there. So great chatting to you all. Best of luck with paper 4, and go out there and absolute smash the exam. All right, bye-bye everybody. Bye-bye.